Hey everybody, Mrs. Bianchi. We're looking at number 5 on 1.3. It's asking you to find the LCM or least common multiple of 5, 8, and 4. Before you begin, it's always a good idea to identify the larger number, which in this case is 8, and ask yourself, is it a multiple of the other two numbers? Now, it is a multiple of 4, but it's not a multiple of 5, so therefore 8 will not be the LCM of the set of numbers. But you always should ask yourself that first before you begin, because sometimes that will work. In fact, there's another question on the homework where that's true. So you have two options here. When you have just single digit numbers, it really, quite honestly, it's usually best to just list out the multiples. So let's start with 5. 5. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. And we'll stop there to see if we need to go further. Let's move on and look at the number 8. 8. Multiples of 8 include 8 times 1, which is 8. 8 times 2, which is 16. 8 times 3, which is 24. 8 times 4, which is 32. 8 times 5, which is 40. And I'm going to stop there, and we'll see if we need to extend any of these lists. Let's move on and start our list for 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Now, I do want to point out something, because some people might say, hey, 20 is in the list for 5, and it's in the list for 4, but it's not in the list for 8. So if this was just finding the LCM of 5 and 4, then 20 would be the answer. Now, if we don't have any matches, then you should keep going with your list of 5. So let's go back to the list of 5. So 5, 10, 15, 20, 25, 30, 35, 40. Now, do you see how 40 is a match in this set? So let's see if it's also a match in the list for 4. So this is an unfinished list: 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7, 4 times 8, 4 times 9, 4 times 10. Now, do you see how 40 is in all three lists? 40 is in all three. So the LCM of 5, 8, and 4 is 40. Now, that took a little while. So let's talk about how we might use prime factorization to also find 40 as the LCM. Now, if we were to make factor trees for 5, 8, and 4, and 5 is prime, 8 we can branch as 2 times 4, and then we can keep going as 2 times 2, and bring down the 2. All right, so remember 5 is prime, so I'm just going to rewrite that down here so we don't forget about it. 4, we can have that be 2 times 2, and that's finished. So our prime factorization for 5 is right here. Our prime factorization for 8 is right here. Our prime factorization for 4 is right here. Now, when you're attempting to do a Venn diagram, it can be a little bit tricky. So I'm going to try to attempt to make 3 circles. So this circle is going to represent the prime factorization for 5, which is, not in common with any others. I'll make the other, in fact, let's color code this. Let's make maybe that red. And then I'm going to clone this circle, but I'm going to change a color, because this other circle will represent the prime factorization for, let's make it this top one, the number 8, but I'm going to change the color of it to being maybe blue, because I think it'll make more sense why I'm doing this in just a second. And then we'll have this circle down here, which I think I'm going to change a color of that to, how about we make that green? All right, so the red circle represents the prime factorization for 5. The blue circle represents the prime factorization for 8. And the green circle is going to represent the prime factorization for 4. Now, if you have a number that's in common in all 3 sets, which we don't, we would put it where the three circles interlock. We have ones that are in common in two sets. So for example, we have this 2 and this 2. And what are they in common? They're in common between the 8 and the 4. So we would put that number right here. Now, what else do we have in common? We have this and this. That's in common, again, between the 8 and the 4. So I'm going to put that right here. Now, what are some numbers that are loose here? Some loose numbers. We have a loose 2. So that went with 8. So we're going to put that here. And we have a loose 5. And we're going to put that here. Now, to find the LCM, which, by the way, we already know to be 40, we would multiply all the numbers contained in the circles, and we would be able to get the LCM. So you can see if we did 5 times 2, if we did this times this, that would be equal to 10. And if we did this times this, that would be equal to 4. And this times this would be 40. So I think that with 3 numbers, you're actually better off listing out your multiples or using maybe a multiplication table, because the prime factorization for 3 numbers can get a little bit ugly. And I think I would even still recommend using list out the multiples, even if we were dealing with bigger, like 2-digit numbers. It would almost be worth it, just because this can be a little bit messy to organize this and a little bit difficult to know where to place the numbers. All right, but so the answer is 40 for number 5.